Welcome to lesson 4.8, Functions and Relations. So earlier this year, we've already looked at functions with the idea of inputs and outputs or domains and ranges. So a reminder, when we're looking at an input-output table for a function, it may look like a two-column table or two different vertical boxes here. And the rule again for a function is that each input has one unique output, meaning that every input has only one output related to it. It's okay for two inputs to share an output, but one input, such as 4, may not have two outputs, like 6 and 8. That would not be a function. So to be a function, each input has one unique output. So then let's look at our new definition for this lesson. In this lesson, we'll be looking at relations, and in math, a relation is any set of ordered pairs. So remember, an ordered pair is x comma y, what you graph. So relation is any set of ordered pairs. Then we get into the idea of function notation. So function notation is a way to name a function that is defined by an equation. For an equation in x and y, the symbol f parentheses x replaces y, and it's read f of x. So an example of function notation, I'm going to jump down a little bit here in the notes, and function notation would be something like this. F of x equals negative 2x plus 1, or f of x equals 4x minus 3. Both of those equations are written in function notation. So you'll notice instead of having a y on this side and it being in slope-intercept form of y equals mx plus b, function notation is simply the f of x replaces the y. And this would mean f of x equals negative 2 times x plus 1. Same thing as y equals negative 2x plus 1. So then, function notation, it's a way to name a function defined by an equation. And that's the key there, where the function piece, f of x, equals some sort of equation. Then the graph of a function. The graph of a function is all the points x comma f of x, where x is the domain of a function. But remember, the f of x piece here is the same as y. So really, the graph of all the points, x comma y, our input or our output, input comma output, where x is the domain of the function. So then we know that the f of x piece right here would be the range of the function, or our y values. So our examples. First, we're just looking at whether the relation is a function. So remember, a relation is any set of ordered pairs, and input-outputs are ordered pairs. This could be written as 1, 3, then 2, 3, 3, 6, 4, 6, and 4, 8. So that would be the relation of all the ordered pairs, just written in a chart this way. So in this case, remember, the domain is always the input values. The range is always the output values. But this one here in A is not a function because our input here of 4 has two different outputs of 6 and 8. Now in B, is B a function? First, we look at our inputs and outputs. Each input has one unique output. Even though 3 and 4 share 9, that is okay. So if we were going to list our domain, it'd be each of the inputs. So 1, 2, 3, 4, and the range would be our outputs, 1, 5, 9. In our ordered pairs, if we were going to write this table in ordered pairs, it'd be 1, 1, 2, 5, 3, 9, 4, 9. So again, two examples here in our checkpoint. Are they functions? If so, give the domain and range. In example A, we have 4 inputs and only one output of 5, but that is still a function because each input has only one output. So our domain would be 1, 2, 3, 4. The range would be 5. In B, it is not a function because this input of 2 has two different outputs, a 2 and 4. Now, if we're looking at a function that is already graphed, there's an easy way to tell if that is a function or not. And that is the vertical line test. So a relation is a function. So if we're looking at a relation that's graphed, we can tell if it is a function, and that way is if no vertical line passes through the graph more than once. So if you would draw a series of vertical lines, and if at no point they cross the graph more than once, that graph is a function. If they cross the graph more than once, it is not a function. So the vertical line test, if it only passes through the graph once, function. More than once, not a function. So let's look at a few examples here. In example 2a, the vertical line, no matter where we draw it, through this graph right here, it only crosses the graph of this figure once. Remember, the x and y axes are not part of the graph. Those are just our plane. So x and y axis don't count as the graph. We're only looking at that figure here in the check mark shape. So the vertical line, no matter where we draw it, only crosses once. So yes, that's a function. In B, vertical line crosses this graph more than once, many different spots where we would draw it. So that's not a function. Checkpoint 2a, you can see a vertical line crosses this graph multiple times, so it is not a function. Even though out here, it only crosses a graph once, over here it crosses a graph multiple times, so not a function. And with B, no matter where we draw the vertical line, it only crosses that graph once, so that is a function. Now into example 3, evaluating the function for the given value of the variable. So our first function is f of x equals negative 3x. So our function f of x equals negative 3 times x, and we're evaluating when x equals 2. So we are going to substitute a 2 in for x. When we do that, we rewrite the function notation of f parentheses whatever number you're putting in for x. So f of x in this case becomes f of 2. And that would equal a negative 3 times 2. So the function of 2, our output, when we input 2, so the input of 2 gives us the output of negative 6. In B, g of x equals 4x plus 20. 4 times x plus 20. We're evaluating when x equals a negative 3. So we're going to replace x with a negative 3, and we're going to evaluate the function when we are inputting a negative 3. So 4 times negative 3 is negative 12 plus 20. Have to do multiplication before addition. And then negative 20 or negative 12 plus 20 is a positive 8. So when we input a negative 3, g of negative 3 gives us the output of 8. Do the same in checkpoint 3 here. F of x equals 3x plus 3, and we're evaluating for x equals negative 3. So f of negative 3 equals 3 times negative 3 plus 3, a lot of 3's. So f of negative 3 would equal negative 33 plus 3. So f of negative 3 equals negative 30. Again, same thing as y equals 11x plus 3. This is just function notation. In B, f of x equals 6 minus 1.75x when x equals negative 10. So again, you can think of this as f of 10 equals 6 minus 1.75 multiplied by 10. Multiply before subtraction, so 6 minus 17.5. So f of 10 equals a negative 11.5. So when we input 10, the output is negative 11.5. So that ordered pair would be 10, comma, negative 11.5 if you were to graph it. Just like here, the ordered pair would be negative 3, comma, negative 30 if you needed to graph it. So speaking of graphing, now we could evaluate using algebra by putting a few numbers in for x, getting our output values and graphing those ordered pairs. Or we can simply think of this f of x as slope-intercept form. So y equals 3/4 x minus 2. So the negative 2 is our y-intercept. So that gives me this point here where we cross the y-axis at 0, negative 2. And remember, you always graph that y-intercept first. So starting at 0, 0, over 0, down 2. Then we follow our slope, and the slope's always attached to x. So our slope is 3 over 4, which tells me, because it's positive, up 3, right 4. So from my y-intercept, I'm going to go up 1, 2, 3, right 1, 2, 3, 4, put my point, and then you can draw your line. Moving down, 2 more graphs. So again, think of these instead of f of x as y equals mx plus b, slope-intercept form. Same thing. So graphing f of x equals negative 2x plus 1. Y-intercept is at a positive 1. So first thing I want to do is graph my y-intercept. Over 0, up 1. There's my y-intercept. Slope is always attached to x, so it's a negative 2 or negative 2 over 1. Because it's a negative, we go down, then right. So down 2, right 1. So from the y-intercept point, down 2, right 1, there's a point. Down 2, right 1, another point. And you can draw your line. And lastly, example B, f of x equals 4x minus 3. So our y-intercept at a negative 3, so over 0, down 3, there's our y-intercept. from that point, we follow our slope, which is 4, or 4 over 1. So we go up 4, right 1. There's our next point. From there, up 4, right 1. There's your next point. And you can draw your line.